Good evening and welcome to the day two of this course, is networking basic to advanced. And in today's session, we will be going through the first and foremost device that we will always come across working with, and we will be always hearing about it in our daily networking jargon. That is the switch. Okay. But again, before we jump into the discussion of what is a switch, how does it work, or what is the purpose of a switch, and how switch helps us to forward the data, let's again go back to a bit of a history of of a general history of why switch was created. We have gone through that particular history in the demo session, but let me just go through that once again. So in the demo session, I had mentioned that my assumption is that the computers were created for faster mathematical calculations, right? So we created a computer which was able to solve mathematical calculations faster, uh, complex mathematical calculations pretty much faster. And as more and more scientists and research started to come up, and they were dependent on the usage of computer. Obviously, more and more computers started to come up, and because more and more computers started to come up, we wanted these computers to share information with each other so that the researchers or those researchers who are using these computer for mathematical calculation, they can share their research and probably publish a paper together, right? That is what probably in olden days, that is what was going on. So for example, there are four computers in this place, and we wanted that these four computers share information with each other, right? So we wanted such a kind of a connection. So you can see that one computer over here, PC number one, right? PC number one is connected to three different other computers: PC number two, PC number three, and PC number four. So one computer is connected to three devices, basically meaning on this particular computer. On this particular computer, yesterday we saw how does an interface or how does a port basically looks like on a switch. So if I want these computers to talk to each other, I need three such ports on PC number one, not just on PC number one. I need, there are four PCs. Okay. In basically, I will need in total of between these four PCs, there should be 12 ports so that they can communicate with each other. Now imagine there are 100 computers, right? There are 100 computers. So obviously one computer would be connected to 99 other computers. That means I should have 99 different ports. I should have 99 different ports in order for that to communicate. Imagine, I showed you this switch which had multiple ports. Imagine those ports, built into your computer, and imagine 99 different ports. How ugly would that look, right? So, creating such huge computer with so many ports, so much of requirement was not feasible. Okay, it was doable, but it was not feasible. We can create, but it was not worth it. And obviously, as technology was growing, my computer would not be just connected to 99 computers. It would become we in today's world, my computer through the internet and through the advancement of technology is connected to millions of computers. I can send messages to millions of computers at a single time, right? So obviously we cannot afford millions of ports on a particular computer. So that's basically a worth, is not even worth it. So what we did was we created a particular device which would help us share that information. Okay. And that particular device was called as a hub. I'm not going to go into much detail about hub, right? But it's just that I can connect multiple devices to this hub. Okay. And if PC number one sends a data, right, this hub would copy that particular data, right, and would share it to all the other devices in that same network. Network meaning the devices which are connected to this hub. will share the information to those devices, right? That was the work of a hub. Now, the advantage was I can connect these 99 different computers. I can connect 99 different computers, and any computer which sends the data, that any computer which sends the data, the hub will basically copy that data and forward it to everyone, whoever is connected to the hub, right? But then, as advancement in the technologies started to happen, and as more and more research started to come up, we wanted that if PC number one sends the data, I do not want PC number PC number three to PC number 3 and 2 to listen to that particular information, because let's say this research, okay, let's imagine that both of them, all of these PCs are being used by physics department. Okay, so back in those days when research was happening, releasing or publishing a paper was a very honorable thing. No, you cannot leak your paper to someone else, right? So now PC1 wants that if whatever research paper he is sending, it should be received only by his partner, that is on PC number 4. PC number 2 and PC number 3, they should not receive it, because they might use that proprietary information, okay, and they may use it for their research. They did not want that. But hub is not a device which will do that, right? It will copy this information, it will also forward it to 2 and 3, right? We did not want that. So a device we created a device which we will be studying about it now, which is basically called as a switch. Okay, the same switch that I showed you in the last session, right? We created a switch. So now PC number 1 can send the data to the switch. Switch will read that data, okay, and forward it to the only intended recipient or intended receiver. Okay, here in this case, that is PC number 4. Right. Similarly, if PC number 3 sends the data or PC number 2 sends the data, it will send it to only PC number 2. Right. So switch was the first intelligent networking device. It was the first intelligent networking device. Hub was a networking device, but it was not as intelligent as a switch. It would just simply copy and forward it to everyone in the network. But here, switch is a device which was intelligent enough to know which sender should it send the data. That was the best use of a switch. And I can connect multiple devices. Okay, on this switch that I showed you yesterday, there were only few ports, but there are switches which have multiple ports. So I can connect multiple other devices to the same switch, and based on my requirement, I can use the switch to send data from one PC to another PC. This was the work of a switch, and this is why we created a switch. Okay, and also the switch is not only used to connect multiple devices together, it is also used to expand your network. Let's say this is building number 1. This is building number 1. I can use multiple switches together. This is switch number 2, for example. I can use multiple switch together, and I can connect these two switches, right? And this switch might be connected to different other PCs. Okay, so what is happening here is that, and let's imagine this is building number 2, right? This is building number 2. So I am expanding my connectivity. So I'm not confined to one single area just because that particular switch has only constraint let's say it has 12 ports. So I can connect only 12 devices. Not like that. What I can do, I can connect 11 devices together and use 11 devices together and use one port of this switch to connect it to different switch like this, right? And this switch will be connected to different other PCs. So what happens in total, I am connecting multiple PCs together with the help of a switch. And it works on the same principle, right? If this PC wants to send a data to a PC which is connected to switch number one, for example, PC number one, it can send the data. The switch will help the PCs to forward the data or send the data to PC number one. Okay, this is basically the function of a switch. But now the main question comes. I have been saying it helps to send the data. I've been saying this word. It helps to send data from one PC to another PC to other PCs. Okay, this is what I have been saying till now. But how does it do it? How does a switch sends a data? This is what we are going to look at in today's session. Okay. So before we jump into that discussion, let's think from a postal office. Okay, postal office. Let's say this is postal office number one, and instead of number one, let me think, or let me from Delhi. This is the postal office in Delhi. Okay, and this is a post office in, let's say, Chennai. Okay, you sent a letter. Okay, now when you send a letter, what happens? So basically, you always give something. There is a format, and the first and foremost thing that you give in that format is a to address and a from address. These two are very important. These two are very important part of a letter in order for the post office to send the data to the post office in Chennai. Right now, what happens from Delhi to Chennai? Obviously, there is not. If you're using again, if you are just considering not airways, if you are considering only roadways or different cities, between Delhi and Chennai, there are different cities. Okay, I'm just denoting these different cities in circle. Okay, I'm not naming the cities. I'm just understand that these are different cities, and these different cities have their respective post office. So when you write a letter, this letter you drop it into the post box. You drop it in the post box, right? The postman picks the letter, takes it to the Delhi's postal office. Right now, the post office in Delhi, what they do is they read the to address. They read the to address, right? Which is basically the destination. This is the destination, right? They read the destination address, and then based on where the destination is, based on where the destination is, they will send this letter to the next post office of the next city. The next city will again read the destination address, forward it to the next post office. Again, this post office will forward it to next post office, and this post office will forward it to finally the Chennai post office. Right. The Chennai post office, what he will read? Again, he is going to read the destination address. Right, the destination address. And based on the area, he will search the post box. Okay, also not the post box, he will search the house. The postman will search the house and send the or deliver the letter to that house. So basically, this is how your postal office is working, and they're forwarding, or in networking term, they're forwarding the data based on the destination address. So in this particular scenario, what are the two things that is required for the post office to forward the data? Okay, let's think from now. Let's think from a device's perspective, or let's think from a post office perspective itself. Any post office, when it is sending the letter or any parcel or any courier, right, to a destination post office, what are the two things that it will look at? Naresh, can you tell me? Just give a random guess. What are the things that it will look at when it is for sending the parcel or letter to the next post office? What it is looking for?
Destination IP and
Hmm? No, think from a postal office perspective.
Mm-hmm. Yeah,
From,
next post office.
yeah, next post office, right? Next post
Mm.
office, and as you said, it will be looking at the destination
Destination.
address, or basically the two address in this scenario, two address, right?
Yes.
These are the two things that it will be looking, right? And first of all, why does it need to look at the next post office? Because as per the map, let's say this is Delhi and here is your Chennai, right? So it would be sending data in, not forwarding the data probably in this manner. It would look for the nearest post office towards the destination post office. Why would a Delhi post office send the letter to a Mumbai post office, which is on the other side? Or why would a Delhi post office send the letter to the Kolkata post office? It would send the letter to the post offices which are on the shorter way towards the Chennai post office. Correct?
Yes.
This is what it's going to do. So similarly, just like a post office, when a switch when a switch is trying to forward a data, okay, switch will also look at two things. Okay, switch over here, multiple PCs are connected. PC number 1, 2, 3, and 4. Right. So when switch is forwarding a data, let's say PC number 1 wants to send a data to PC number 2. Okay. So when PC number 1 is forwarding a data, it will write the to address of PC number 2 and from address of PC number 1. Right. Now, from a networking perspective, this to address and from address is basically called as a MAC address. In networking, this is called as a MAC address. This to address and a from address is called as a MAC address. Okay, the full form of Mac. It's not the Apple Mac. Okay, that we Mac PC, Mac OS, etc. No, that's not the Mac we are talking. This is Mac. Its full form is Media Access Control. Media Access Control Address. In short, MAC address. Okay. And just like our house address is unique across the globe, anyone across the globe, whoever is writing a letter to me, he will use a particular address. He will use my house address, and my house address is unique to me. No one else, no one else in this entire earth will have the exact same house address as mine. Correct? Similarly, address, a MAC address is unique, is universally unique. No device, okay, no networking device, let's say networking device. Every networking device, every networking device has a MAC address, and that MAC address is unique. No other networking device will have the exact same MAC address ever. So even in today's world, there are so many devices. There are millions, trillions, zillions probably of networking devices. When I say networking devices, it includes obviously laptops, PCs, you have servers. Okay, you have servers. Then you have these our smartphones. You have smartphones. You have smart TVs. Okay, smart TVs, all of them have a MAC address. Okay, so that is why I said the count is beyond our comprehension. The amount of networking device that is present in today's world is beyond our even counting capability. So all of these devices have a MAC address, and as I said, it's unique. It is unique. We'll talk about MAC address probably a bit later in detail, right? But using a MAC address, the switch is able to forward the data. The switch is able to forward the data. Okay. Now, let me show you how does a MAC address basically look like. So over here, you can see it's written as destination and it is written as, okay. Leave all the other information, forget about all the other information that you see on the screen. Just concentrate on the MAC address that I'm showing you. So over here, this is a MAC address, B8, B7, DB, 3C, 7238. This is a MAC address of a particular device. Similarly, this one, source, it says F4A475072E6B. It is also a MAC address. And this is how in networking, a MAC address is basically shown or is written as or is understood by networking devices. It's not like our house address where we have a flat number, then a building name, a building flat number, building number, society, then area, then city, then state, etc. No, that's not how the address or a MAC address is written in networking. It's written like this. Okay. Now let's talk about a bit on MAC address. MAC address, MAC address is a 48-bit value. It is a 48-bit value. 48. Okay. When we are talking about 48 bits value, meaning ones and zeros, there are multiple ones and zeros, basically 48 ones and zeros. Okay. It's a 48-bit value, right? And this 48-bit value is basically divided into, this 48 is divided into 6 portions. Okay, it's not divided by 6. Okay, it is not divided by 6. This 48 bits of value is divided into 6 different parts. Okay, 6 different parts, right? So, and as you can see over here, this MAC address, you can see it is divided into 6 different portions. Okay, 6 different portions which are separated by a colon. You can see these 2 dots, which is a colon, and you can see 6 different such values. B1, B8 is one value, B7 one value, DB one value. So 1, 2, 3, 4, 5, 6. So as I said, it is divided into 6 portions. Okay, it is divided into 6 different portions, and those 6 portions are called as an octave. Is called as an octave. So it is divided into 6 octaves. It is divided into 6 octaves. Why octaves? You can ask. Why octaves? Why is it called as an octave? So in this MAC address, you can see, I'll take the first value, B8. The first value over here, it says it is B8. B8. Okay. Now let us convert this B8. This is in a hexadecimal format. This is in a hexadecimal format. If you convert this hexadecimal format into their binary equivalent, if you convert them into their binary equivalent, you will see this 8 is written as 1 0 0 0. 9 is 1 0 0 1 1 0 1. Okay. And B is written as 1 0 1 1. Okay. B is written as 1 0 1 1 and 8 is written as 1 0 0 0. Okay. Now, yeah. So you can see why is it called as an octave. We know that octa means 8. So you can see here 4 plus 4. 4 plus 4, which is basically 8 bits. That is why it is called as an octave. So each of these octaves, B8 is an 8-bit binary number, B7 is an 8-bit binary number. DB is 8 bits. 3C is 8 bits. 72 is 8 bits. 38 is 8 bits. How 8 bits? If you convert them into their binary equivalent, then it becomes an 8 bit. So, and one octet, you can see if one octet has 8 bits, 6 octets will give you 48 bits, which is basically your MAC address. Okay, and you just saw how a MAC address is written. MAC address is basically written in that format, like B7 colon B4 colon AB colon 57. Okay, 1 2 3 4. Okay, 5 6 7 8, like this. It is written in this format always. Okay, you will always see MAC addresses written in this format anywhere. Any text you read on internet or on Google or everywhere, anywhere in a book, or if you are in a customer environment or on a device, you will always see the MAC address like this. Okay, and as I said, this MAC address is given to every networking device. When I say networking device, I mean any device that can be connected to the internet. Okay, that can be connected to the internet is a networking device. And every networking device in the world has a MAC address, which is unique. Right? So you can easily see it's a 48 bits value. To be unique in nature, just make this as 2 power 48, and whatever value you get, that number of MAC addresses can be created. Combinations of MAC address, not that number, many combinations of MAC addresses can be created. Okay, so with so that many combinations of MAC addresses could be created, right? So this is why the MAC address in the world or in the world of networking is unique in nature. All right, any question? Okay, now let's try to understand how does a switch uses these MAC addresses to forward data. Okay, so let me draw the same switch over here. Switch. Let me connect multiple PCs. PC number 1, 2, 3, and 4. Okay. And for simplicity's sake, let us assume that all these PCs will have a MAC address because they are networking devices. So obviously PCs will have a MAC address. And now, okay, before I move forward, the MAC addresses are part of the layer 2, which we saw in the demo session. It is the part of layer 2 of your OSI layer model or your TCP IP model. It comes into the layer 2 of the OSI layer model. And I told you this OSI layer model or a TCP IP model is present inside your networking device. So this MAC address is present at the layer 2 of your OSI layer model inside the device. Okay. Now, so as I said, every networking device will have a unique MAC address. And just for understanding and simplicity sake, let us think that the MAC address of PC number 1 is 1111, meaning that all the 48 bits, of PC number 1 is 1111. Okay, in short, I'm just writing it as 111. Similarly, for PC number 2, it is 2222. For PC number 3, 3333. And PC number 4, it is 4444. Okay, so this is the MAC addresses of different PCs. Okay, and I showed you the switch yesterday. and I showed you different ports or interfaces on the switch. Correct? Those different ports have numbers on them. Let me show you. I'm not sure if you can see those numbers, but let me try to show you that number. Give me a minute. So you can see these numbers, right? 1, 2, 3, 4, 5, 6. These numbers, right? So when you connect a particular PC into these different ports, okay, these different ports, right? So you connect it to, you say I have connected PC number 1 on port number 1, PC number 2 here, PC number 3 here, 4 here, etc. on different ports. Okay, so on my diagram, the diagram that I am going to show you, okay, or that I'm going to draw. Okay, I'm going to number these ports as well. So over here, PC number 1 is connected to port number 1, 2, 3, and 4. These are the respective ports of that particular switch. Okay, now let's assume that PC number 1 wants to send a data to PC number 3. Let's assume PC number 1 wants to send a data to PC number 3. Okay, imagine PC as a human. So if PC number 1 wants to send a data to PC number 3, if it is writing a letter, what it will do, it will write a to MAC address, right? To MAC address, that is 3333, and a from MAC address, and a from MAC address, that is 1111. Correct? And it will send the data, or it will send the data, right? Switch will read the MAC address. It will see that this data needs to be sent to a PC which has a MAC address of 3333, and it will forward the data to PC number 3. This is how it should happen. Generally, this is how it should happen. But before this forwarding of data, before the switch can so easily forward the data like this, it goes through multiple steps first. It goes through a multiple step. Okay. Let's rewind back to our post office scenario. So over here, you can see for the post office to send the letter to the destination post office, it needed the to address and it needed the next post office's address. Okay, here also this was an address. Similarly, for a switch, it also needs addresses. One is the MAC address that we are already aware of. Now, switch keeps a map. Okay, imagine yourself, instead of post office, imagine yourself as a person going from one place to another. You will be looking into the map, correct? You will be looking into the map how to move forward. Or imagine yourself using the GPS, Google Map. Okay, you will be constantly looking at the map how to go to a destination, to take a right, to take a left, or to take a right, or to go straight, etc. You will be looking into those things. Correct? Similarly, a switch also has a map. A switch also has a map that is called as a MAC address table. This is the map of a switch, which is called as a MAC address table. Okay, that is the what do you say? That is the map of a switch. And this map of a switch, it keeps a note of different things. And what is that note? It keeps a note of the MAC addresses. It keeps a note of MAC addresses, and it keeps a note of the ports on which these MAC addresses are connected. Okay, these are the two main important things that a MAC address table contains. It will keep a note of the MAC addresses, and it will keep a note of port numbers on which these MAC addresses are connected. Okay. Now, please remember, switch is a networking device. Okay. When a switch is powered on, okay, this switch, I'm sorry, with my background, I don't think you will be able to see the switch. This switch that I'm showing you right now, okay, if I power this switch on, when I power this switch on, right, it will also have a MAC address. It will also have a MAC address. It will have its own MAC address table, but the MAC address table like this, it will be completely empty. It will be empty. There will be nothing inside this MAC address table. It will be completely empty. Okay. So imagine yourself using Google Map. You opened Google Map and the Google Map is not showing you anything. Basically, what happens? You are lost. There is no point of using the Google Map. Similarly, when a switch is powered on, its MAC address table is completely empty. So if the MAC address table is completely empty, and imagine this PC number 1 sends the data, how is this switch going to forward the data to PC number 3 when its MAC address table is empty? Right? Its MAC address table is completely empty. Basically, its map is completely empty. How will it know how to send the data? Correct? But a switch has a very intelligent way of keeping a note of it. Switch, as I said, switch has a very intelligent way to keep a note of. And how does it do so? Let's try to understand that. But before I move on, any question up till here? Is everything clear? Are you with me till this point? Okay. So now PC number 1 sends the data. Okay. The switch receives it. The switch will receive it. Switch will see the data. When the switch sees this data, what it does is it has a unique way of filling up its empty MAC address table. And how does it do so is when the switch receives the data, it will read the from MAC address. And let me remove the English word to and from, and let me write the exact networking term, that is the source MAC address and the destination, MAC address and the source MAC address. So here, what PC is going to do, it will read the source MAC address. It will read the source MAC address. You will see that, okay, I have received a data from a device. It does not know if it is a PC, if it is a router, if it is a printer, if it is a switch, if it is another switch, if it is some kind of device. Switch is completely unaware of the type of device that the data is coming. It only is aware of the MAC addresses. It does not know what kind of device it is. Is it a PC? Is it a server? Is it a laptop? Is it a smart TV? Anything? No, it does not know. It just knows the MAC address. So here it says that I have received a data, okay, from a device which has a source MAC of 1111. So let me make a note of that MAC address. 1111 is the source MAC, which is the MAC address. And on which interface did I receive it? I received the data on the interface number 1. So I will make a note of interface number 1. Okay. Now, the next thing. Now, to forward the data, obviously, it needs to read the destination MAC address and then make a decision. But again, this destination MAC address is not present in the MAC address table of the switch. So basically, you imagine you are using the Google Map. Because of internet issue, the Google Map stopped showing you, or the Google Map basically froze. So you're clueless how to go, where to go. Right. Similarly, when the data is with this switch, The data is now received by the switch, but the switch does not know how to forward the data or where is this MAC address connected to. It is completely unaware of it. So here, what the switch does is, it does not take any risk. It does not take any risk. And what it does, it will broadcast it, or it will forward it out of all the interfaces that has connection. So it will forward it to PC number 2, it will forward it to PC number 3, it will also forward it to PC number 4. Okay, again, it's not forwarding to those PCs, it is forwarding out of those interfaces. Interface number 2, interface number 3, and interface number 4. But PC number 2 will reject this particular data. PC number 4 will also reject this data. Why? Because their MAC address is not 333. It is not 3333. That is why they will reject this particular data. The only PC that will accept this data is PC number 3 itself, because it has the matching MAC address. So imagine a parcel has or a letter is received. So the letter is sent. Okay, letter is sent. Now imagine the post office does not know the correct address. You forgot, or the post office does not have a list of how to forward the data. So imagine this post office forwarded the data to all the houses in the city. All the houses rejected this letter except the intended house. So PC number 3 has received it. Now it is going to respond. When it responds, the source MAC is going to be PC number 3's MAC address, and the destination MAC is going to be 1111, which is PC number 1's MAC address. Correct? And now the PC number 3 will send this data back. Okay, this data is now received by the switch. Now, again, switch makes the same decision. It looks at the source MAC address. Where is this data coming from? Okay, I have received the data. I have received a data whose source MAC address is 3333. And I received this data on interface number 3 of my chassis. Right? Done. It made a note of it. Then second thing it checks is, do I know this destination MAC? Is it present in my MAC address table or not? Yes, it is present. Here it is present. Now, instead, previously, when it did not know the 3333 MAC address, it basically broadcasted it out of, or forwarded it out of all the interfaces. But in this case, since it is aware of the MAC address and out of which port it should send the data to, the switch, instead of forwarding it out of all the interfaces, it will forward only through interface number 1. It will forward through only interface number 1. And hence, PC number 3 will be able to send the data back to PC number 1. And in this scenario, the switch is not going to forward the data because the destination MAC address was present in the MAC address table. Earlier, when in the opposite direction, when PC number 1 was trying to send the data to PC number 3, 3's MAC address was not present in the MAC address table, and hence the switch had to forward the data out of all the interfaces. But in this scenario, when the return traffic is coming back, the switch is aware of the destination MAC address, that is 111, and how to forward the data. It needs to forward the data out of interface number 1, and hence it will forward the data only to PC number 1 and not out of all the other interfaces. So with this, what we can conclude or what we can understand is that, first, a switch will populate its MAC table when it receives a data. Okay, again, it will populate using the source map. Source map. So this is a very important thing. Until and unless a switch receives a data, it will not populate the MAC address. And when it populates the MAC address, it will populate using the source MAC address and not the destination MAC. It will always populate using the source MAC address. Okay, this is the first point. Second point is that if the destination MAC is not present in the table, switch will forward it out of all the interfaces. Forward the data out, forward it out of all interfaces. Okay, this is the first thing that we saw, right? Then second thing, or not second, third thing. If the destination MAC is present, okay, switch will forward it out of the respective interface. Okay, so these three things we saw or we learned of how the MAC address table and how switch is basically populating the MAC address table and how is it forwarding the data. All right, now let's consider another example here. PC number 4 wants to send a data to PC number 2. Okay, let me erase these MAC addresses. All right, any question up till here? Clear. Now let's imagine this MAC address table is full. I mean, with the MAC address of PC number 1 and PC number 2, right? So now let's imagine PC number 4 is sending a data to PC number 2. Okay, so destination MAC, the source MAC is going to be 4444, and destination MAC will be 2222, which is PC number 2. So switch will forward the data. Sorry, PC will forward the data. Switch will receive it. When switch receives it, we can say it will populate using the source MAC address. So it will read the source MAC address. It sees that the source MAC address is not present in the MAC address table, and hence it will make that entry. So our data is received with a source MAC of 4444 on the interface number 4. The destination MAC is 2222. Is the destination MAC present in the MAC address table? No. That means the second point. If the destination MAC is not present in the table, switch will forward it out of all the interfaces. That means this data again is forwarded out of all the interfaces. Right? PC number 1 will reject it. PC number 3 will reject it because the destination MAC is not 222. So PC number 2 will receive it. When PC number 2 will receive it, it will respond. When it responds, the source MAC is 2222. Destination MAC is 4444. Okay. Now again, this data is sent to switch. Switch will first it will populate using the source MAC address. So it sees that a data is received with a source MAC of 2222. It's not present in my MAC address table, so let me make an entry of it. And it was received on interface number 2. Second, if the destination MAC is present in the MAC address table, switch will forward it out of that respective interface. Correct? So destination MAC is present in the MAC address table. So instead of sorry, what was the destination MAC? Destination MAC is 444. Yes. Here the destination MAC is present in the MAC address table. So the switch will forward it out of that respective interface. That is 4444. Sorry, interface number 4, and it will be forwarded to PC number 4. Right. Now, what happens? The MAC address table of the switch is complete with the 4 devices. Now, any future communication that happens between any PC, it can be between 1 and 4. Okay. If PC number 1 sends the data to a PC number 4, switch will know how to forward the data to 444. Right? It will read that the destination MAC 4444 is connected at interface number 4, and it will forward the data to PC number. Right. So once the destination MAC is present in the MAC address table of the switch, it will make sure that the data is forwarded out of that particular interface. And if not, it will forward it out of all the interfaces in the which are connected to that particular device. Clear? Any question? Okay. So with this, we are, I will stop the session for now today, because with this, I don't want to bombard with too many information today. Okay. So we just looked at what is a switch, how does a switch, why was a switch created, and how switch can help us expand the network in a larger geographical location, right? And we understood how the switch uses a MAC address to forward the data, right? And we just saw how basically switch is populating the MAC address table, right? This is what we saw. And in tomorrow's class, we will look at the practical of it. We'll just see, I'll show you the lab for this, how the switch is forwarding the data, how the switch is learning the data, etc. All right.